Hi everybody. So this is, we're just going to go over the problems that I gave you a couple days ago, and they were due in class today. But we're going to be doing something else in class, so hopefully this will help you go over the problems, and if you still have questions, we can go over them tomorrow. So the first one, just want to get into this. Thunderstorm is coming. You see a flash of lightning and begin counting the seconds till you hear thunder. 10 seconds later you hear the thunder. Knowing sound travels 340 meters per second, how far away is the lightning bolt? So the first thing you have to realize is thunder doesn't really, or sound doesn't change its speed. So the VI and the VF are both 340 meters per second. And that basically means that the acceleration is 0. So we also know that the time is 10 seconds. So I just got rid of the 10, but time is 10 seconds. And we are looking for the displacement, the distance, how far away is the lightning bolt. So knowing that the A is 0, we can use the following equation. V equals D over T, because we have a D, a T, and we have a V. So 340 equals D, which is what we're solving for, over the time, which is 10 seconds. So let's erase that. Time is 10 seconds. And multiplying both sides by 10. 10 seconds goes away on both sides, and 340 times 10 is 3,400 meters, which is 3.4 kilometers away. So it's pretty far away. Next, the slowest animal ever discovered is a crab found in the Red Sea. It travels with an average speed of 5.7 kilometers a year. How long would it take this animal to travel 100 kilometers? And strangely enough, I think I'm just going to leave this in years because it's going to take years. So I know the normal units would be meters and seconds, but just in my head, if it goes 5.7 a year and we want it to go 100 kilometers, we're going to talk about many years. So I don't want to go into seconds. I think that's kind of overkill. So we know that the velocity initial and final, because it just tells us the average speed, it's telling us that it only goes 5.7 kilometers per year. The acceleration is 0. The time that we're giving it is what we're looking for. Sorry, we're not giving it, but we want to know 100 kilometers. Okay, so again, using the equation V equals D over T, we know the V is 5.7 kilometers per year equals the displacement, which is 100 kilometers over time that we are looking for. So we're going to have to, I'm going to make this a t. So we're going to multiply both sides by t because we have a variable in the denominator. Okay, so the t's will cancel. And then we're left with 5.7t equals 100. So we're going to divide both sides by 5.7. And because of this, we're gonna, this is kilometers, and that's kilometers, and that's kilometers, that's kilometers. So that's gonna cancel, and we're gonna be left with an answer in years, which I think is fine. So 100 divided by 5.7 is going to be 17.54. Time is 17.54 years. And if you want to convert that to seconds, you can. I'll do it real quick. 17.54 years times 365 days per year times 24 hours per day times 60 minutes per hour times 60 seconds per minute. It's a whole lot of seconds. 553141440 seconds. So that's actually why I should have told you not to bother converting it into seconds, but that's what you do, so that's how many seconds it would take. Okay, next. Oops, that's not what I wanted to do. A blue jay, because that was the last one. Okay, blue jay sits in a tree awaiting its dinner. His mom lands on the nest. She drops a worm towards the chick's mouth, but misses. The worm falls from the nest to the ground in 1.5 seconds. How high is the nest? So now we're dealing with a different set of equations because now we actually have a projectile, and we know that because we have something that falls, which automatically means that the acceleration is negative 9.8 meters per second squared. We also know that she drops it, so the initial velocity for anything that's dropped is 0 meters per second. And we want to know how high the nest is. So that's what we're looking for, the displacement. And we also know that we've got a time of 1.5 seconds. So they don't give us the final velocity and they don't ask for the final velocity, so we don't really care about the final velocity. So we need to find an equation that's got a VI, A, T, and D, which for my money is D equals VIT plus 1/2 AT squared. We've used this equation a lot. So we're finding the D. We know that times 1.5 plus 1/2 negative 9.8 times 1.5 squared. So this is going to be 0 because 0 times 1.5 is 0. So D equals, and half of negative 9.8 is negative 4.9 times T squared. 1.5 squared is 2.25. 2.25. So 2.25 times negative 4.9 is a displacement of negative 11.025 meters. So that's how far it falls. So the nest is positive 11 meters high because there's the tree or the mushroom cloud, as the case may be. But the thing drops 11 meters, which means it started here at 11.025 meters high. Next, a giraffe who stands 6 meters tall bites off a tree branch to chew on the leaves. He lets the branch fall to the ground. How long does it take the branch to hit the ground? So now, again, we're dealing with something that's being dropped. So the initial velocity is 0. The final velocity we're not asked about because it's falling. The acceleration is negative 9.8. The time excuse me, is what we're looking for. And the displacement is negative 6 meters. And that's really important because the thing falls 6 meters. So we have to remember that that's a negative 6 for the displacement. Again, I think the equation to use is going to be D equals VIT plus 1/2 AT squared because we have a VI, A, T, and D. So we know the displacement is negative 6. The VI is 0 times T, which we don't know, plus 1/2 times negative 9.8 times T squared. So the good news here is, yes, this is technically a quadratic function, but 0 times T is going to be 0. So negative 6 equals negative, so let's see, that's 0. Half times negative 9.8 is negative 4.9 T squared. Let's divide both sides by negative 4.9. Negative 6 divided by negative 4.9. That's going to be 1.22 equals T squared. And then we'll take the square root of both sides and get square root, of 1.22, 1.1. So the time is 1.104, so 1.1 seconds. Hope that helped. I hope that's what you got. Next one, King Kong carries Fay Ray up a 321 meter tall Empire State Building. Top of the skyscraper, her shoe comes off her foot. How fast will the shoe be moving when it hits the ground? So now, something's falling, so the acceleration is negative 9.8. We are given the distance because the Empire State Building is 321 meters, so the displacement is negative 321 meters per second squared. And they only give us a VI of 0 because we know the shoe drops, but they don't tell us the VF, and that's what we're looking for. So they don't give us a T, nor do they ask us for a T. So what we're going to do is we're going to use a different equation, one that's got a VI, a VF, an A, and a D. So for my money, I think that's going to be VF squared equals VI squared plus 2AD. So VF squared is what we don't know. We know VI squared is 0 squared plus 2 times negative 9.8 times negative 321. So this is going to go away. So VF squared equals 2 times negative 9.8 times negative 321. It's a big number. 6291.6, but that's VF squared. We don't want VF squared, we want VF. So we're going to take the square root of that to get technically plus or minus 79 meters per second, but because it's going down, we get rid of the positive, so it's a negative 79 meters per second, 79.3 meters per second. Hope that helped. And I think this is the last one. Nope, almost last one. Billy the goat, bad joke, is climbing the rock when when a rock comes hurling towards him from the ledge 40 meters above. Billy ducks and avoids injury. Good, thank goodness. How fast is the rock traveling, and how does this be compared to a car traveling 25 meters per second? Okay, so the rock comes hurtling from 40 meters above. We can assume that it came from rest because it was a rock, so the initial velocity is 0. We are looking for the final velocity. We know the acceleration is negative 9.8 because we're dealing with something that's falling again. The time we don't know and we're not asked for it, but the displacement we know is negative 40. So again, VI, VF, A, and D. I think the equation to go with is going to be VF squared equals VI squared plus 2AD. VF squared equals 0 squared plus 2 times negative 9.8 times negative 40. So 2 times negative 9.8 times negative 40. That's going to give us a VF squared of 784. We don't want VF squared, we want VF, so we got to take the square root of both sides. So 28 VF is technically plus or minus 28 meters per second, but we don't want the minus, or the positive. Hate when the light shuts off. Because you remember from math class, whenever you take the square root of something, it's technically plus or minus. So we're going to take the negative because velocity is a vector quantity and it's going down. So we're going to take the negative 28 meters per second squared, which is faster than 55 miles per hour. Because 25 is 55 miles per hour. Last one, Reverend Northwick climbs to church belfry one morning to determine the height of the church. From an outside balcony, he drops a book and observes that it takes 2 seconds to hit the ground. How high is the balcony, and why would it be hard to do this if he only drops one piece? We talked about the one piece because of air resistance. So B is air resistance. But he drops a book, so that's less of a problem. We know again we're dropping something, so the initial velocity is 0. We are looking for how high the balcony is, so we're looking for the D. We know the time it takes 2 seconds. The acceleration for something that's dropped is negative 9.8 meters per second squared. And the VF we're not asked about. So we need a VI, A, T, and D. I'm going to say the best bet is going to be, once again, D equals VIT plus 1/2 AT squared. So D is what we're looking for, equals 0 times 2, but that's going to be 0, plus 1/2 of negative 9.8 times 2 squared. So D equals negative, let's see, 1/2 of 9.8 is 4.9 times 4. So 4.9 times 4 is 19.6, negative 19.6. So D is negative 19.6 meters. Boom. I hope that made sense, and I hope that helped you out with your homework. And if you have any questions about it, we can talk about those questions tomorrow. Okay? See you in class.